Alright, so in this problem, I have 2 to the power of 3 to the power of 4 to the power of x is equal to 512. So to solve this, I'm going to first start by rewriting 512. So 512, this is the same thing as 16 times 32. And now I can write this as 2 to the power of 3 to the power of 4 to the power of x is equal to 16 times 32. Now 16 is equal to 2 to the power of 4, and 32 is equal to 2 to the power of 5. So this is why we wrote 512 as 16 times 32, because now I have 2 to the power of 4 times 2 to the power of 5, and notice how we have another base of 2 over here, 2 to the power of 3 to the power of 4 to the power of x. So now I can rewrite this as 2 to the power of 3 to the power of 4 to the power of x is equal to 2 to the power of 4 times 2 to the power of 5. Now all my terms are bases of 2. Now if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So right here we have 2 to the power of 3 to the power of 4 to the power of x is equal to 2 to the power of 4 times 2 to the power of 5, which is the same thing as 2 to the power of 4 plus 5. And 4 plus 5, that's equal to 9. So 2 to the power of 3 to the power of 4 to the power of x is equal to 2 to the power of 9. And also, instead of doing all that, remember over here how we had at the start 2 to the power of 3 to the power of 4 to the power of x equals 512. 512 is equal to, well, we know that 2 to the power of 5 is 32, so 512 is 2 to the power of 5 times 2 to the power of 4, which is 2 to the power of 9. So we could just said at the start that 512 is equal to 2 to the power of 9, but some people don't know that 2 to the power of 9 is equal to 512, so that's why we had to do all of that. So now going back here, we have 2 to the power of 3 to the power of 4 to the power of x is equal to 2 to the power of 9. And now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, we can say that m is equal to 3 to the power of 4 to the power of x, and n is equal to 9. So because these two bases are the same, this means that 3 to the power of 4 to the power of x is equal to 9. Now, 9 is the same thing as 3 squared. So now I have 3 to the power of 4 to the power of x is equal to 3 squared. And now again, I can use this property because both my bases are the same. So this means that 4 to the power of x is equal to 2. And now 4 is the same thing as 2 squared. So I get 2 squared to the power of x is equal to 2. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x is going to equal 2 to the power of 2 times x, which is 2 to the power of 2x. This is equal to 2. Now, I'm going to use this property again. 2 is the same thing as 2 to the power of 1, so then because these two bases are the same, I get 2x is equal to 1. And now, if I divide both sides by 2, these two cancel out, and I get x is equal to 1/2. So now, to check, my original equation was 2 to the power of 3 to the power of 4 to the power of x is equal to 512. So I have 2 to the power of 3 to the power of 4 to the power of x is equal to 512. and we said that x is equal to 1/2. So I have 2 to the power of 3 to the power of 4 to the power of 1/2 is equal to 512. Now I'm going to work my way down from the top. So I first start with 4 to the power of 1/2. Now 4 to the power of 1/2 is the same thing as the square root of 4. And the square root of 4 is equal to 2. Meaning I have 2 to the power of 3 to the power of 2 is equal to 512. Now from here, 3 to the power of 2 is equal to 9. So I have 2 to the power of 9 is equal to 512. And finally, 2 to the power of 9, that's equal to 512, as we already said at the start. So we get 512 is equal to 512. Alright, so in this problem, I have 9 to the power of x plus 12 to the power of x is equal to 16 to the power of x. So what I'm going to do is first start by dividing both sides by 9 to the power of x. So this means that I get 9 to the power of x over 9 to the power of x plus 12 to the power of x over 9 to the power of x is equal to 16 to the power of x over 9 to the power of x. Now, 9 to the power of x over 9 to the power of x, those two cancel out, and I get 1. So I have 1 plus 12 to the power of x over 9 to the power of x is equal to 16 to the power of x over 9 to the power of x. Now, from here, I can rewrite this as 12 over 9 to the power of x, and 16 to the power of x over 9 to the power of x, I can rewrite this as 16 over 9 to the power of x. Now 12 over 9, that simplifies to 4 over 3. And 16 over 9, that simplifies to 4 squared over 3 squared. Now 4 squared over 3 squared, that's the same thing as 4 over 3 squared. And now I have this to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So 4 over 3 to the power of 2 to the power of x, I can rewrite that as 4 over 3 to the power of x to the power of 2. And now I'm going to let 4 over 3 to the power of x equal to the variable u. So if I substitute in u for 4 over 3 to the power of x, I get 1 plus u is equal to u squared. And now if I subtract u and 1 on both sides, these two cancel out, and I get u squared minus u minus 1 is equal to 0. Now, to solve this equation, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get u is equal to negative of negative 1 plus or minus the square root of b squared negative 1 squared, which is positive 1, minus 4 times a, which is 1, times c, which is negative 1, all over 2a, so 2 times 1. And this is equal to positive 1 plus or minus the square root of 1 plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So we have u is equal to 1 plus or minus the square root of 5 over 2. Now, remember how we let 4 over 3 to the power of x equal to u. Well, this means that 4 over 3 to the power of x is equal to 1 plus or minus the square root of 5 over 2. Now, this gives me two equations. I get 4 over 3 to the power of x is equal to 1 plus the square root of 5 over 2, and I get 4 over 3 to the power of x is equal to 1 minus the square root of 5 over 2. Now 1 minus the square root of 5, that's going to be a negative number. And notice how this is a positive number to some power. Well, you can't take the power of a positive number and make it equal negative, meaning there's no solution to this equation, and all that's left is this equation. So, to solve this equation, what I'm going to do is start by taking the log on both sides. So I get log 4 over 3 to the power of x is equal to log 1 plus the square root of 5 over 2. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front, so it's going to equal b times log a. In this case, I have log 4 over 3 to the power of x, and I can move x to the front. So I get x times log 4 over 3 is equal to log 1 plus the square root of 5 over 2. So now that x is a term, we can isolate it by dividing both sides by log 4 over 3. So when these two cancel out, and I get x is equal to log 1 plus the square root of 5 over 2 over log 4 over 3. And log 4 over 3, I can rewrite that as log 4 minus log 3.